All right, we're moving on to section 5.4, and that's something called a sum and difference formula. It's going to take us away from our trig identities for a few days, so hopefully there'll be a nice break from that, and then we'll have our test next week. So before we start this, I want to go over a couple of things here up at the top. The first one would be that if I asked you to find the cosine of 60 degrees, you could look on your unit circle and you could tell me that that was 1/2. And if I asked you to find the cosine of 45 degrees, you could look on your unit circle real easy and tell me that that's the square root of 2/2. But if I asked you to find the cosine of, let's say, 105 degrees, that's like our first problem down here we're going to do in a second. Well, you can't look on your unit circle to find that, can you? Because it's not one of our values. So we're going to learn a quick, easy, repeatable method to find the exact value of a lot of different angles, even though they're not on our unit circle. And so they follow a formula, and our formula is going to have these two symbols in it, alpha and beta. And up here, we're just going to write out that alpha and beta are angles on the unit circle. Okay, so that'll help you when you're figuring these out. The numbers that are going to go right here for the alpha and the beta have to come from the unit circle. So if you have the cosine of two of these unit circle values added together, that's always going to equal the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Now that may seem confusing, but I promise in a minute it's going to seem simple. Okay, when we have the difference between two unit circle values, that's always going to equal the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. So this is just like a little sideways A looking thing, and this is kind of like a B with a little bit longer side on it. So don't get too worried about it. If you need to put A and B, that's fine. All right, the way this works is when we have a problem like this that says the cosine of 105 degrees, well, we're going to try to split that up into the cosine of some angle from our unit circle plus or minus, we're not sure which one all the time, plus some other angle from our unit circle, right? So if you just had to think about that, how do you make 105 with unit circle values? So unit circle values like these are like 30, 45, 60, 120, 135, things like this, right? 270, 330, anything that's on the unit circle that we always use. So 105 is the same thing as 60 plus 45. All right, so 105 is 60 plus 45. So 60 is the alpha and 45 is the beta. It would not matter if you did it in the opposite order. It would still come out the same. So what that leads us to is doing this formula. The cosine of alpha plus beta equals the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Okay, and then all we do is use our unit circle and realize that the cosine of 60 is 1/2. The cosine of 45 is the square root of 2/2 minus the sine of 60 is the square root of 3/2, and the sine of 45 is the square root of 2/2. So all this gets multiplied together. So 1 times the square root of 2 is the square root of 2 over 2 times 2 is 4. And then square root of 3 times square root of 2 is the square root of 6 all over 4. We have a common denominator. So that equals the square root of 2 minus the square root of 6 over 4. And there's no other way to simplify that, so that's all we can do. If there is something that can be simplified, obviously we'll always simplify it, but for that, that's all we can do. So we're going to take a look at the next one. It says cosine of 7 pi over 12. I want to change that one to make this problem work out a different way, so let's just scratch out the 7. So we're just going to have the cosine of pi over 12. Now, if we're trying to break this up into the cosine of something plus or something minus something else, right? We don't know, maybe we do plus, maybe we'll do minus. It's hard to do with radians because they're radians. So we're going to take this and convert it into degrees. So that gives us 180 over 12, which is 15 degrees. So now this we're going to change to 15 degrees for the purposes of figuring out our alpha and our beta. So 15 degrees, well, think of our numbers we can use. We can use 60, we can use 30, we can use 45. All the numbers from the unit circle are available, but to get to 15, that's less than our smallest number, 30. So we're going to have to use two numbers from our unit circle that subtract to make 15, because 15 is smaller than everything. So we're going to do the minus, and two numbers that make 15 would be cosine of 45 minus 30. So now we're going to plug in our formula. So it's cosine, remember 45 is the alpha, 30 is the beta. So cosine alpha, cosine beta, plus sine alpha, sine beta. And then we go to our unit circle. We say it's cosine of 45, square root of 2 over 2. Cosine of 30 is square root 3 over 2, plus sine of 45, sine of 30. Okay, all that equals across the top, square root of 6 over 4, plus square root of 2 over 4. So we have the square root of 6 plus the square root of 2 over 4. And again, that's as simple as we can do it, because we can't square root 6, we can't square root 2, so we're just done. All right, just like cosine, there's a pattern for sine, and of course it's different, so we're going to have two different patterns to remember, but don't forget, you'll have a formula card on the test. So for sine, we have two unit circle values added together. That's always going to be equal to the sine of alpha times the cosine of beta plus the sine of beta times the cosine of alpha. So sine, cosine, sine, cosine. And then for the minus, it's sine alpha cosine beta minus sine beta cosine alpha. Okay, so nothing too complicated. If you change the order of these two, that doesn't matter. If you change the order of these two, doesn't matter, because it's multiplying, so everything works out fine. All right, real quick, we're going to do the sine of 15 degrees. So that's the same as the sine of, and let's say 60 minus 45. You could pick any values you want, but I like to pick the smallest ones possible, or some of the smallest ones. Makes it easier to think about. So this is going to be sine of alpha cosine beta minus sine beta cosine alpha. And something that I do a lot, because I say these out loud, is I accidentally write the beta. So 45. All right, then we look at our unit circle. We say, what's the sine of 60? Square root of 3 over 2. What's the cosine of 45? Square root of 2 over 2. Those get multiplied together. Minus square root of 2 over 2. Cosine of 60 is 1/2. So we get square root of 6 over 4 minus square root of 2 over 4. Square root of 6 minus square root of 2 over 4. So that's going to be kind of a recurring answer. You may see a lot, combinations of square roots of 6 and square root of 2. Not always going to be that, but they showed up a lot here. So this is an example of using the sum and difference formulas to kind of work backwards. Here we see that we have the cosine of 50 times the cosine of 10 minus the sine of 50 times the sine of 10. So if you can think about that like our formulas are written, this is the cosine of some angle times the cosine of another angle minus the sine of the original alpha angle times the sine of the other beta angle. So what this says is cosine alpha cosine beta minus sine alpha sine beta. And if you look back to your original formula, we can see right here we have cosine alpha cosine beta minus sine alpha sine beta. So that's cosine of alpha plus beta. So we look back over here, this is equal to the cosine of alpha plus beta. So it's the cosine of 50 plus 10. So it's cosine of 60, which you know is 1/2. So these are definitely easier, I think. They take less time. You just have to recognize them. So we'll scoot down here, find the exact value. So we have sine alpha cosine beta plus cosine alpha sine beta. Okay, so it goes sine alpha cosine beta plus cosine alpha sine beta. So we look back at our patterns. We know it's a sine pattern because it goes sine cosine. So this one says sine alpha cosine beta cosine alpha sine beta. Doesn't matter what order. Remember, the multiplication can go either order. So head back over here. This is going to be sine of alpha plus beta. So this is sine of 5 pi over 12 plus pi over 12. So this is sine 6 pi over 12, which is really sine pi over 2. Sine of pi over 2 is 1. All right, last example. This is definitely the most thinking type of question, but it's still not too bad. All right, we have suppose that sine of alpha equals 4 over 5 and sine of beta equals 5 over 13. Well, anytime I read that, I think immediately this is an opposite and this is a hypotenuse. And then sine of beta, this is also an opposite and this is also a hypotenuse. Now for different angles, but they're still both opposites and both hypotenuses. Now it says alpha is in quadrant 1. Beta is in quadrant 2. And then it says find cosine of alpha plus beta. Well, that's good because we just learned a formula for that. So the cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. So pretty easy. We already know that sine alpha is 4 over 5, and we know that sine beta 5 over 13, right? We're just going to multiply those together and subtract them from whatever these two are. But to find the cosines, we're going to have to use this information they gave us. All right, so we're looking for our alpha, we're looking for our angle alpha. And remember, since it's in the first quadrant, that means it's in here somewhere. And the angle is always the acute angle formed with the x-axis. So we're going to draw straight down. Our opposite from that angle is 4. Our hypotenuse is 5. And hopefully you recognize this is a 3, 4, 5 right triangle. If you didn't, you would do the square root of 5 squared minus 4 squared, get the square root of 9, which is 3. And that would tell you that that's 3. So the cosine of alpha is adjacent, which is 3, over hypotenuse. So now we just need to figure out what the cosine of beta is, multiply everything together, subtract it, and we'll be done. So angle beta. Second quadrant. Always the acute angle. So our opposite is here, so this is 5, hypotenuse is 13, and hopefully you remember there's a 5, 12, 13 right triangle, except that because it's in the second quadrant, we know that the cosine is negative. means the x value is negative. So this 12 is negative. So the cosine of angle beta is negative 12 over 13. Then we're going to multiply everything together. Negative 36 over 65 minus 20 over 65, same denominator, 36 minus 20, negative 56 over 65, and that is the value of cosine of alpha plus beta. Not pretty, but repeatable, and something I think you'll be pretty good at. So that's it. Have a great day.